Welcome to your Business Calculus Lesson 2.3. We're going to be defining the laws of limits and defining continuity. Okay, so if B and C are real numbers, and N is a positive integer, and F and G are functions with the limits, as X approaches C, F of X is equal to L. As X approaches C, the limit of G of X is equal to K. So, if the limit as X approaches to C of B is where B is the constant, a real number, that limit is going to equal B. Okay. The limit as X approaches C of B times F of X, it's going to equal B times L, or B times the original limit as X approaches C of F of X. If you take the sum or difference of the two functions and you take the limit, it's going to be the sum or difference of the original limits. If you multiply the two functions together and approach the same value, approach C, then it's going to equal the product of the original limits, L times K. And if you do F of X over G of X and you take the limit as X goes to C, or as X approaches C, you're going to get the original limit of F of X and the original limit of G of X, L divided by K, where K isn't equal to 0. Okay. We've talked about continuity in a very informal way, and now we're going to define it formally. A function is continuous at X equals A if the limit as X approaches A of F of X is equal to F of A. So to show this, you must, to show that F of X is continuous at X equals A, you must show that F of A is defined. So you need to find that value. You need to show that the limit as X approaches of F of X exists. So in order to do that, you're going to have to show that the limit from both sides exists and they are equal to each other. And then you want to show that the limit as X approaches A of F of X is equal to F of A. Okay, so you need to practice this. You need to know that this is a process that has several steps to it. Okay, we're going to determine whether F of X equals X squared minus 9 over X minus 3 is continuous. So since this isn't specifying a value, it's asking, is the function defined for all values? That's the first hurdle. And then we can start talking about whether it's continuous for all values. If you look at F of X, it's equal to X minus 3 times X plus 3 over X minus 3. There is a hole at X equals 3. And set the X minus 3 equal to 0. So it's undefined. So F of X is not continuous at X equals 3. So we cannot say that the function is continuous everywhere. Okay, we're going to determine whether the function G of X equals X squared minus 9 over X minus 3, so long as X doesn't equal 3, and where it equals 2 if X equals 3. So is it defined for all values? Yes. Okay. X equals 3 could cause a problem, but the fact that there's a different rule for X equals 3, that the function equals 2 there, that takes care of that problem. Let's find the limit as X approaches 3 of G of X. And so that's going to be 6. Okay, we would, at first, we get our indeterminate form, and then we simplify, and we'll get X plus 3 left, and 3 plus 3 is 6. So the limit exists, and it exists from the left and the right. They are equal. And then G of C equals G of 3 equals 2. Okay, the limit, the value that we're interested in, our specific value is 3, and our function does define it as 2. So we run into the problem here that although the limit exists, the limit does not equal the value of the function evaluated at this same X value. So the function is not continuous. All right, let's look at another example. We're going to find a constant a so that the function is continuous on the entire real number line. And so we have f of x equals ax plus 2 for x less than 4 and x squared for x greater than or equal to 4. In order for continuity to exist, f of 4 must be defined. Well, f of 4 is equal to 4 squared is equal to 16, so it's certainly defined. The limit as f of x approaches from both sides must also equal 16. This will be true if we can find a value of a so that both pieces of the function equal 16 at x equals 4. So what we're going to do is we're going to plug in 4 everywhere we see x, and we're going to set the function rule for the two pieces equal to each other. So ax plus 2 has to equal x squared when x equals 4. So we're going to have a times 4 plus 2 equals 4 squared. So 4a plus 2 is 16. We're going to subtract 2 from both sides and get 4a equals 14. Divide by 4, and we get 14 over 4, and so we get 7 halves. If a has 7 halves, then we do have a continuous function. Okay, thank you so much for watching the video. Complete what you can of the problem set, and then we'll continue to work on it in class. You know where to find me if you have any questions. I hope you have a great day.